Welcome, everyone. Today we are exploring a critical component of analyzing requirements for AI-powered business solutions, organizing your business solution data so it is fully available and optimized for various AI systems. Welcome to our first slide, where we dive into the foundational pillar of AI-powered business solutions, organizing your data so it can be effectively consumed by other AI systems. What exactly does this mean? It means transforming raw, scattered data into structured, secure, and highly accessible knowledge. Let us start with the why. If your data is poorly organized, your AI systems, whether they are Microsoft 365 Copilot instances, autonomous agents, or custom generative AI applications, will suffer from weak grounding. They will produce inaccurate information and drive unreliable decision-making. Organizing data is not just an IT task, it is a critical business imperative. Throughout this training, we will explore how to take scattered data silos and convert them into a unified data estate that powers high-confidence, enterprise-grade AI interactions. We will cover the what, why, how, and when of preparing your enterprise data for the AI revolution. Let us take a look at the flowchart on your screen. On the top left, we have the current state for many organizations: fragmented, disconnected data silos, and unverified databases. When you feed this directly into an AI model, the output is highly unpredictable. The middle section represents our transformation process: data organization, structuring, and centralization. This is the crucial organizational bridge that connects raw information to usable intelligence. Finally, at the bottom, we have our diverse ecosystem of AI systems, including Microsoft 365 Copilot, custom agents, and Azure AI applications. By funneling our raw data through this organizational bridge to create a unified data estate, we ensure that every single AI system draws from a governed and accurate source of truth. This diagram clearly illustrates why our organizational efforts are the absolute critical dependency for enterprise AI success. Moving to our second core principle, centralization. This is the where of your data strategy. To make data available for other AI systems, you must aggressively move away from scattered data silos. How do we actually achieve this? We leverage robust enterprise platforms like Microsoft Azure, Dataverse, or Microsoft Fabric to build a unified data estate. This involves consolidating data from your operational applications, customer relationship management systems, enterprise resource planners, and unstructured document libraries into a single, manageable ecosystem. By establishing operational databases for structured app data alongside analytical stores like Fabric Lakehouse for curated data, you create a comprehensive foundation. When AI agents need to reason over complex business context, they should not have to navigate a dozen disconnected systems. A centralized data estate ensures that AI has a unified view of your business reality, which drastically reduces latency and significantly improves the relevance of AI-generated responses. This architecture diagram visualizes the data centralization process. Notice the outer nodes on the left representing various fragmented data sources, CRM systems, ERPs, and unstructured document libraries like SharePoint. The arrows converge into the central hub, labeled Azure Data Estate. This central hub acts as the brain of your data operations. It is logically divided into operational databases, which handle real-time structured data, and analytical stores, which manage massive volumes of curated data for deeper analysis. By bringing the data into this unified layer, we create a powerful single access point. The outgoing arrows on the right point directly to the AI systems. This means that no matter which specific AI agent or application is asking the question, it queries the centralized data estate, guaranteeing consistent, governed, and real-time answers across your entire organizational footprint. Now that we have successfully centralized our data, we must focus heavily on the how of data formatting, normalizing, and structuring. AI systems, despite their incredibly advanced natural language capabilities, perform significantly better with standardized schemas, strict naming conventions, and consistent metadata. What we are actively doing here is preventing data pollution, the degradation of data quality that negatively impacts AI reliability and performance. If you have duplicate records, conflicting taxonomies, or noisy, unstructured formatting, your AI agent will struggle to retrieve the precise context needed to execute a task accurately. Clean data is characterized by clear structure, zero duplicates, minimal irrelevant metadata, and highly predictable layouts. By investing the necessary time and engineering effort to normalize your data upfront, you ensure that the embedding and retrieval processes later in the pipeline operate with maximum precision, ultimately leading to highly accurate, Trustworthy AI outputs. Look closely at this sequential flowchart, which details our data normalization pipeline. We start at the very top with raw data ingestion, where information enters our system in various states of disarray and complexity. The next critical step is the data cleansing and noise removal node, where we explicitly strip out irrelevant noise, remove duplicate entries, and fix broken formatting. From there, the clean data flows down into the schema normalization node. This is where we apply consistent naming conventions and perfectly align the data to our enterprise-wide schema. Next, we hit the metadata and taxonomy tagging node, enriching the data with structured tags so the AI knows exactly what it is looking at. The final output node at the bottom is AI-ready structured data. This diagram highlights that data readiness is not a magical overnight transformation, but a rigorous, step-by-step engineering pipeline. Let us take a deep dive into the intelligence layer, specifically focusing on semantic indexing and vector embeddings. Once your data is perfectly clean and structured, how do AI systems actually understand it? We convert your enterprise content into rich lexical and semantic representations, which are known in the industry as vector embeddings. This is an absolutely critical step because Microsoft 365 Copilot, Copilot Studio, and custom AI agents rely entirely on semantic indexing to ground content correctly. Instead of just searching for exact keyword matches, vector search allows the AI to understand the underlying semantic meaning and context of the data. For instance, if a user asks about company time off, the semantic index is smart enough to pull data regarding vacation policy or PTO. By building a robust intelligence layer with Azure AI Search, we ensure that the AI agents retrieve the most contextually precise information possible. This diagram elegantly breaks down the mechanics of the intelligence layer. On the far left side, we see our structured data flowing directly into the embedding model. The embedding model's job is to translate human-readable text into mathematical vectors, capturing the true semantic meaning. These vectors are then safely stored in the semantic index database node located in the center. Now, follow the path from the bottom left. A user query enters the system, which is also rapidly converted into a vector by the vector search engine. The engine compares the user's query vector against the entire semantic index to find the closest mathematical and contextual matches. Finally, the best matched data flows into the grounding context node on the right, perfectly formatted and ready to be fed to the AI model. This visual completely captures the mathematical bridge between raw business data and intelligent AI comprehension. Building directly on semantic indexing, we must discuss the overarching architecture that puts it all together, the Retrieval Augmented Generation, or RAG, pipeline. A RAG pipeline is the essential architecture that separates simple, unreliable AI prototypes from trustworthy, production-ready enterprise systems. What exactly does it do? It performs all the complex steps required to make real-time, governed data available to a large language model without ever exposing the underlying database directly to the model's training set. The pipeline seamlessly handles indexing, retrieval, and prompt assembly. When an AI agent needs to answer a user's question, the RAG pipeline rapidly retrieves the most relevant context from your organized data and dynamically injects it into the prompt. This empowers the AI with real-time, domain-specific knowledge, preserves strict enterprise data privacy, and serves as the primary defense mechanism against AI hallucinations in critical business applications. Here we have a detailed architectural view of a production-grade RAG pipeline. At the very start of the flow, the user prompt is submitted at the top left. Notice carefully how the flow splits. One path goes down to the retrieval engine, which intelligently searches our previously built semantic index for highly relevant business data. The retrieved data's specific grounding context flows into the prompt assembly node. Here, the original user prompt and the retrieved enterprise data are combined into a single, highly enriched instruction set. This enriched prompt is then securely sent to the large language model node. Finally, the LLM processes this grounded context to produce the trusted grounded response at the bottom. This diagram visually emphasizes that the AI model is not merely guessing based on its generic training data, but is being explicitly guided by your meticulously organized business data. Once your data is beautifully centralized, structured, and indexed, the next major step is determining exactly how to expose it. To truly make your business solution data available for multiple, distinct AI systems, you must provide multiple access paths. Different AI agents simply consume data differently. An autonomous task agent built in Copilot Studio might prefer to connect via a REST API or a Power Platform connector, while a custom generative AI application built natively on Azure might need to directly query a vector search index or a SQL endpoint. By designing your data architecture with high interoperability in mind from the start, you ensure that multiple AI systems can securely tap into the exact same source of truth. This completely eliminates the need to duplicate data for every new AI project. You create a robust, scalable data service layer that serves as a universal adapter for any authorized AI agent in your enterprise. This diagram brilliantly illustrates the concept of multipath data exposure. Right at the center is our pristine, AI-ready data estate. Radiating outward from this central hub are different access interfaces tailored for specific systems. We have a Node 4 REST APIs at the top, a Node 4 vector search indexes in the middle, and a Node 4 graph connectors at the bottom. On the far right edges, various AI consumers are perfectly connected to these specific interfaces. You can see Copilot Studio agents securely connecting via the APIs, custom Azure AI apps pulling data via the search indexes, and Microsoft 365 Copilot seamlessly connecting via the graph connectors. This radial design clearly shows how a single, well-organized data foundation can easily support a diverse, expanding ecosystem of AI applications simultaneously, without any data duplication. A critical aspect of organizing data for AI systems is governance, and the golden rule here is to implement it early. When data becomes highly accessible to intelligent AI systems, the inherent risk of oversharing sensitive information increases dramatically. AI agents, like Microsoft 365 Copilot, use a specific retrieval API which strictly honors user permissions, meaning an agent can only ground its responses based on data the active user already has access to. Therefore, your underlying data organization must include robust role-based access controls and accurate sensitivity labels. Utilizing enterprise governance tools like Microsoft Purview allows you to establish strict access policies, comprehensively track data lineage, and enforce data quality rules at massive scale. By embedding this governance into your data architecture from day one, you ensure that as your AI systems scale, they automatically respect compliance boundaries and protect intellectual property without requiring retroactive security patches. Take a look at this streamlined governance flow diagram. The critical process begins on the top left with our raw enterprise data sources. Before this data can ever be indexed or retrieved by an AI, it must pass through the central gateway, the Microsoft Purview governance block. Inside this governance layer, we see strict sub-processes enforcing sensitivity labels and RBAC and DLP policies. Only data that has been properly classified, masked, and governed is allowed to flow down into the secure retrieval API. Finally, at the bottom right, the authorized AI agent queries the API, and the API filters the response based exclusively on that specific user's permissions. This flowchart demonstrates that governance acts as a vital, unbreakable security filter, guaranteeing that AI agents only surface information that is fully compliant with your organizational access policies. Our final slide focuses on the most crucial ongoing aspect of your organized data, keeping it authoritative and updated over time. Timeliness is absolutely essential. AI systems must reference the latest, most accurate information to be effective. If your grounding data becomes stale, your AI outputs will degrade rapidly, leading to outdated policy advice, incorrect business insights, and a complete loss of user trust. While the semantic index in Microsoft 365 is brilliantly designed to continuously update as content changes, for custom databases and analytical stores, you must actively establish rigorous data refresh schedules. This means diligently monitoring modified dates, managing seasonal or compliance-related updates, and ruthlessly retiring obsolete documents. By ensuring that your data remains clean, accurate, and timely, you sustain the high reliability of your AI agents over the long term. This continuous maintenance transforms your data estate into a living foundation that empowers all future AI innovations. This final diagram illustrates the continuous lifecycle of AI data management as a dynamic, circular flow. We start at data ingestion and indexing at the top left, representing the entry point of fresh data. Following the arrow clockwise, we move to active AI consumption, where agents actually use the data to assist users and drive business value. The flow then moves down to continuous telemetry and monitoring, representing the ongoing, automated oversight of data quality, relevance, and AI performance drift. From there, We move to data refresh and deprecation on the bottom left, where obsolete, outdated data is permanently removed and new data is flagged for immediate updates. This step loops right back into data ingestion. This infinite loop emphasizes that organizing business data is not a one-and-done IT project, but an ongoing operational cycle that guarantees your AI systems always have access to authoritative truth.